In the last lecture, Scott kind of described the basic principles of event-driven programming. In event-driven programming, event handlers respond to events that arise whenever you hit a key, you click a mouse, you click on a button. In event-driven programs, the various handlers need to share a common set of information that allows you to make your interactive program run. In this lecture, I'm going to talk about one technique for making all these handlers work together. The idea is we're going to have them share a common set of global variables. Now, up to now, we haven't distinguished between global and local variables. In this lecture, I'll describe the difference between the two. I'll show you some examples of where we can use and maybe should use global variables, and I'll show you examples where we shouldn't use global variables. So maybe this will give you a little bit of background behind how we're going to approach the first few weeks of class. So let's talk about global and local variables in Python. So you're already familiar with building global variables. You've done it a fair bit. Anytime you define a variable outside a Python function, you're building a global variable. So for example, if I say num1 is equal to 1, I have just defined and used the global variable num1. Now it turns out you've actually built local variables also. You just didn't know that. When you built rock, paper, scissors, lizard, Spock, you created, for example, a local variable to hold the computer's guess. You then later on use that local variable to do some further computation to figure out who won. Variables that you create inside a function are called local variables. So let's go through and make an example. So I'm going to define a function fun, and I'm going to define a local variable num2, and we're going to make it num1 plus 1. And then let's just print out num2. And then we'll need to call that function. So I'm going to say fun. And let's run that and see what happens. So when we called fun, it said let's make a local variable num2, and value should be the value of the global variable. We can use this global variable in here, num1 plus 1. So then we ask it to print it out. So print it out too. Now you might ask, well, what's the distinction? I don't see any difference here. So let's just do a little test. So down here, after I've run the code, I'm going to now print out the value of num1. And if I do that, well, num1 is still 1 after I ran my function. Okay, no mystery there. Let's just see if we can get the value of num2. So I'm going to say print num2. It says error, num2 not defined. So the critical distinction here is that any variable you create inside a function can only be modified and used inside that function. It's local to the function. It doesn't exist after we've finished calling the function. We can't access it. We can't share it between two different calls of the function. It's created once inside the function. You can modify it in there. You can use it. But it goes away when the function call ends. So that's the definition of why we call it a local variable. On the other hand, num1 always exists. It's there for the entire run in Code Sculptor. We can use it inside functions. We can use it outside functions. Now this leads to one interesting question. So what I'm going to do is I'm going to get a modification of my function fun. I'm going to do something you shouldn't really do. But I want to point out something interesting about how Python works. So I'm going to go through in here and I'm going to try to do the following. I'm going to go through and I'm going to make this variable called num1, and I'm going to define it to be 2. So now I'm going to run my code. Let's see what happens. So I'm going to postpone this for right now. I'm going to run it. And what happened? So we printed out num1, it was 1. Then we ran this function, and inside there we said num1 is equal to 2. Then we said num1 is equal to num1 plus 1. It printed out 3. Then we printed out num1 again. A little strange. Well, see, inside the function it said num1 is equal to 2. That seems to be understandable. We changed the value of num1 to be 2. Then we said, well, num2 is 2 plus 1. That's 3. We got a 3. But it printed out, it said num1 is 1 here. What happened? We went through and we said num1 is equal to 2. We created a new local copy of num1. So it's not really good to reuse variable names like it. There's a global num1 here, and there's a local num1. So I made a second local num1 and actually changed its value to 2. When the function finished executing, that local version disappeared. And when I asked to print the value of num1 down here, well, the global variable still exists, and so it printed out a 1. So the critical thing to understand in here is that if I try to actually go through and even modify a global variable inside this in fun here, it's impossible. I can't do it, at least the way I've done it right here. So the critical thing to notice is anything that you create and assign inside a function is going to be a local variable. So let's do an example where we construct a function and use local variables inside it. So the example that I want to consider is this problem of converting Fahrenheit to Kelvin. So let's make a function that does that. So we're going to do that, and we're going to use two local variables in here. So let's do it. We'll say define Fahrenheit to Kelvin. It's going to take the Fahrenheit as parameter. And we're going to create two local variables. One is going to be the value if we convert it from Fahrenheit to Celsius. We'll hang on to that for a second before we try to convert to Kelvin. So let's see, we could say Celsius is equal to 5/9 times, let's see, the Fahrenheit minus 32. And then what do we need to do? We need to go through and then add something to that temperature in Celsius. And what we need to do is we need to add the temperature in kelvins of 0 Celsius. So let's just make a constant that does that. And I think that was 273.15. So with those two local variables, we can now actually compute the answer very easily. We could say return Celsius plus 0 Celsius in Kelvin. And let's actually just print out maybe one test call real quick here. Let's do it for 32 degrees. So we'll run that. It says we have this, oh, looky there, missed an underscore. So it says that 32 degrees Fahrenheit, that goes to 0 degrees Celsius, which when you add in the magic number of 273.15 goes to 273.15 degrees Kelvin. Let's test it on one more value real quick. Let's do it on boiling. So boiling is 100 degrees larger. So let's talk about when you should use a global variable versus when you should use a local variable. In practice, you should always prefer using local variables unless you have a specific reason not to. Let me give you an example. Imagine you're building the software systems for a new modern airliner. You have to write the flight control systems, and you also have to write the in-flight entertainment systems. If you decided, hey, I'm going to make everything global, I could easily see a situation arise where you have a variable dial in your flight control system that maybe is, I don't know, some instrument dial. And you could have a variable dial inside your entertainment system that might be maybe the reading of one of the dials that the passenger uses to control the audio. I think you can agree that it wouldn't be a good idea to do this because you don't want, for example, one of the passengers changing his audio settings to then cause one of the instrument dials to change in response. So that's a place where it's clearly in your best interest to use local variables to capture information that's only local to each of these systems. Using global variables also gives you kind of the ability to really introduce fairly mysterious behavior. So let me show you with this example. So here I have an example where I've made this variable num, it's a global before. Then I've defined two functions, fun1 and fun2. I've hidden their bodies. And then I printed out the value of num before I call fun1, after I call fun1, and after I call fun2. So what you can see here, the values are 4, 5, and 6. Now, I told you beforehand that if we tried to reference num inside fun1 or fun2, Python automatically created a local variable that only existed while we were executing fun1 or fun2. And we couldn't even modify this global variable num. So how did I do that? Well, Python has a facility to do this. What you do is if you would like to access the global copy of num, you have to go through and declare num to be a global. You say global num. Now, any reference or any definition of num afterwards modifies or uses the global variable. Note you don't have to say global if you're just using a global variable. You only really need to say this if you actually want to update a global variable. So here We defined num to be global. We updated num to be 5. That's why we got 5 here. Then here we defined num to be global. We updated 6. That's why num was 6 here. So global variables have the ability to both be dangerous and introduce kind of mysterious side effects. That's why they're tough to program with. So why did we choose to use global variables in our introduction to event-driven programming? They're the simplest way for the various event handlers to communicate data between each other. Okay, when you're building guess the number, you're going to have an input handler and a couple of button handlers. Those are going to need to be able to modify common variables. Using global variables is kind of the simplest way to do this, has the least programming overhead. When we get to object-oriented programming, there are other techniques that give you a better way to hide information, to control how much information is visible. And we'll talk about that a little bit later in the class. But it requires a fair bit of